Hey Math 1, this is Mr. Roberts, Shasta High School. I'm going to look at some of the odd exercises in lesson 2.4. We're talking about inequalities, compound inequalities, and the fact that compound inequalities that are joined with and can be written in compact form. If they're joined with or, you can't do that. Another thing is it's probably a good idea to make sure things read correctly from left to right. In fact, I'll just tell you right now, this bothers me, how they wrote number one. Um, 22 is greater than or equal to x, which is greater than -4. Normally, when I write things involving inequalities, I write the smallest things to the left, and I go to the right. So for me, the preferred way to write this would be -4 less than x. So here I'm saying x's are greater than -4, but they are also less than or equal to +22. Now you can see that this is the same information that they have in their answer. The difference is that the smallest item here, the -4, is all the way to the left, and the larger item, the +22, is all the way onto the right. To me, this just makes sense because when I think about a number line, and I think about the numbers on the number line, we tend to put the smaller ones like -4 over here, and then here might be like the number 0, and then way over here somewhere might be like 22. So I'm just writing them in the same order. And the x's are those things that, run in between those. Anyways, you'll see them do that occasionally with the answers. Just check and ask, hey, Mr. Roberts, is my answer equivalent to the correct answer? And yeah, it is. And I would accept, this answer here. It just kind of drives me crazy. So I know why they did this, by the way, too. They did this because as they're reading it, they're saying all numbers less than or equal to 22. So they're taking care of this item first, and greater than -4. They're taking care of that one next. So that's why that's happening. All right, number 2, all numbers less than 55 and greater than 45. So I want values of x that are greater than, not greater than or equal to, just greater than 45. So you can see here the 45 is the smallest. And they have to be less than, all numbers less than 55. Less than 55. Now this is unfortunate because I just did one of the even exercises, which I wasn't supposed to do. So I guess I'm not that sad, but I'm a little sad. Let's jump to number 5. Number 2 you got on your own, I guess. Number 5, all numbers less than or equal to 87 and greater than or equal to 83. So again, I would start with this 83, and they both say or equal to, so I'm using this symbol. So here I have all numbers x that are greater than or equal to 83. The x's are greater than or they equal to 83, and they are less than or equal to 87. Again, this is my preferred answer because I'm showing the smallest things on the left and going to the largest items at the right. Number 9 we're going to do next. It says write an inequality for each graph. So here I have a graph. This to me looks like all values of x that are strictly greater than 7, right? I'm not saying or equal to. And the reason why I'm not saying or equal to is because these are open dots, which means that these boundary points, the 7 here, are not included. So x's are greater than 7 and x's are less than 25. Again, open, so the boundary point is not included. Number 11, here you can see I'm using closed dots, closed. So these boundary points are included, right? So I'm going to include these boundaries. And this is all values of x. Let's see, the smallest, let's see, -11, 12, 13, 14. So x's are greater than or equal to -14, right? And they are less than or equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can count 5. Again, if I have solid dots, right, that means I'm including those boundary points. Whoa, get back here. So I'm including those boundary points, so I would use the less than or equal to or the greater than or equal to. And if I have an open oops, if I have an open boundary point, right, then I'm using strictly the less than or the greater than, which is, this is being awfully jumpy on me, which is awfully cute because if you draw that, then you can like maybe, put like, I don't know, actually maybe those are the eyes. I don't know what that is. I'm just doodling. Number 12. No, we're not going to do 12. And we're not doing 13, 14, 15. You're on your own. We will look at number 17, though. These directions here say graph the inequality. So I'm given this inequality. I'm supposed to produce its graph. My boundary points are at negative 35 and positive 50. And negative 35 lives about here. And because it says greater than or equal to, right? Well, it says negative 35 is less than or equal to, but the x's must be larger. So x's are greater than or equal to negative 35, include the boundary point, and x's are less than or equal to 50, so I'm including the boundary point right there. Probably I should grab a different color so this is more easily distinguishable. I'll use this funky green. And I love this. I'm going to actually put a ruler down on this and try and draw a line that connects those. There we go. So all of these green points in between and the boundary points are solutions for this particular inequality. Any x in that zone, it's good to go. Let's jump to question 21. The directions are write a compound inequality for each situation. There's two flavors of compound inequality. We can have those that are joined by or those that are joined by and. If they're joined by and, of course, we can write them in their compact form, which is what we've been doing so far exclusively. Kyle's car gets more than 31 miles per gallon on the highway, or 26 miles or less per gallon in the city. All right, it's more than 31. Kyle's car gets more than 31 miles per gallon on the highway. Let me write these separately here. So Kyle's car gets more than 31 miles per gallon on the highway. Gets more than. Or 26 miles or less per gallon in the city. So this is the word or that's joining them. And the other one is 26 miles or less on the city. So it can be 26, but it's or less than 26. So this is interesting. This is the first problem that we've done in this video where I had to join these with the word or. And I want to try and think about logically why this is the case, right? There aren't numbers that satisfy both of these conditions. These conditions are exclusive, right? You can't be greater than 31 and less than or equal to 26 at the same time. So that's clearly why there's no and here. So x's are either, if you're driving in the highway, right, always highway. This is not very good for highway mileage. Highway, it's more than 31 miles per gallon. I do that easily. And, if you're crazy and you drive, like 3 car lengths behind a semi-truck, you probably push it up to 42. That might be illegal, I don't know. And then driving around the city, all the crazy stop signs and the people and stuff, and you got to stop and speed up and slow down. He gets 26 miles or less. So the 26 would be the upper end of that, or less than that. So that's number 21. 23, at the high and low store, clever name, they sell high-end items that sell for over $1,000 and low-end items that sell for less than 10. It says, like, wait, can I get a power drill that's $50? No, that's a different store. We only sell super expensive stuff or relatively inexpensive stuff, but nothing in between. So if I was going to represent their prices here, they sell they sell high-end items that sell for over $100 or over $1,000. So this is interesting. One of the things they can have is they can have items that are more than $1,000. except I need a zero, a 1 in front of that. So the items can be more than $1,000. And then the other part of that is that, and low-end items that sell for less than $10. So we've got some items that sell for less than $10. Now, when they use the word "and" here, and it's really deceptive and makes me slow down and think about this because it really is not an "and" situation, right? Although they sell things in this category and that category, values of X can either be less than 10 or they can be greater than 1,000. But there are no numbers that can be both less than $10 and greater than $1,000 simultaneously. So this is clearly joined by the word "or," and it kind of is one of those things where it illustrates the fact, hey, we got to think about this, right? Yes, they threw the word "and" here, right? But the word "and" here is just saying the two categories of items they sell. It says nothing about the compound inequality in its nature, right? So the prices are either less than 10 or they are greater than 1,000. There are no numbers that are less than 10 and greater than 1,000. It's just mathematically impossible. Let's see, we're looking next at question 29. And the directions for 29 says, represent the solution to each part of the compound inequality on the number line. Then write the final solution that is represented by each graph. Then write the final solution that is represented by each graph. So we're going to kind of do two inequalities, and we're going to make them float above like they are, and then we're going to write one that represents the combination of those two with the word "and" or. We're doing 29 together, which is an odd exercise, and it says that x's are less than or equal to -1. So I'm going to start by calling this 0, and I'm going to call that -1, and that would make this -2. And these are halves, so that would make this 1, and this would be 2. Let me spread this out a little bit. X's are less than or equal to -1. So part of my answer is I've got this right here. Oh, no, you know what I do? I want to be clever with the colors here. I'm going to pick the color yellow for this first one. So X's are those things that are less than or equal to -1. So obviously my boundary point is a solid line, and my arrow is going, oops, my arrow is going this way. Nice. And then the other one is, or X's are greater than 0. And I'm going to grab a nice blue color for that. X's are greater than 0. And that's an open boundary point, and it goes this direction. Jeez, I got to be quicker with that. And it goes this direction. Well, when I look at it, it is clearly an "or" situation, isn't it? It's possible for numbers to be both of those. So on my number line, the solution is this, right? We've got our boundary point here. We've got an open boundary point at 0. And these are going to the right. And these are going to the left. This doesn't quite look like an open boundary point. Make that better, an open boundary point. Let's see, 29. We're going to do 31. Oh, good. This is an "and." X's are less than 9, and they are greater than, or less than or equal to 9, and greater than or equal to 2. So we're going to call this, I'm going to call this 0, and I'll call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, and boy, my spacing does not look very good, right? I would be terrible as a ruler factory. X's are less than 9, so I've got less than or equal to 9, so I've got this open boundary, closed boundary point, and it's those things that are less than that. And the other one is X's are greater than or equal to 2, so I've got, again, a closed boundary point here, and it's those things that go this direction, right? Now, when I look at it, what they share in common, right, if I just go like dot, 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 right, is I've got a closed boundary point here, and I've got this closed boundary point here. and x's are those things that are in between. So all of these x's in between satisfy both parts of this inequality, right? All of these values are both greater than or equal to 2, and they are less than or equal to 9. Let's see, 33, the directions will be on. I believe the directions are solve each compound inequality, then graph and describe the solution. So we're going to do 35 together. They're joined by or. And if I, we're going to just solve each part of these separately. So if I look at the first part of this, right, x plus 5 is greater than 14. And then I've got the or, and the other part will be 3x is less than 9. For this first, the left-hand part here, right, if I subtract 5 from both sides of this inequality, I certainly will get things that are, they still will share this same direction and inequality relationship. So subtracting 5 from both sides, we get that x's must be greater than 9. Or the other part of this, we're going to divide both sides by 3. And notice I'm dividing by a positive 3. And I get therefore that x's must be less than 3. So the two boundary spots are x's have to be less than 3. So let's set up our number line here. I'll call this 0, 1, 2, 3, 4, 5, 6, 7, 9. X's are less than the number 3, so here's 3. Open boundary point, and we're going to go to the left of that boundary. And then the other one, X's are greater than 9. So 3, 4, 5, 6, 7, 8, and 9. Here's my 9. Again, an open boundary point, and X's are those things that are to the right of that. All right, that's basically it. Good luck with the rest of the exercises. Read slowly, pay attention to details, and I look forward to seeing you in class.